All right, this video is about linear programming. All right, here's your vocabulary. Linear programming, a method for finding a minimum or maximum value of some quantity given a set of constraints. Constraints. Constraints are simply limits. All right. Feasible region. The graph of a system that contains all the points that satisfy all the constraints. And lastly, objective function. The quantity that you're trying to maximize or minimize. Make sure you write these down. We're going to go over these, of course, in the video, so they should become clear if they're still kind of fuzzy. All right, key concept. And again, we'll go over this more in the video, but I want you to write this down. Vertex principle of linear programming. If there is a maximum or a minimum value of the linear objective function, it occurs at one or more vertices of the feasible region. So write that down. Now, in this video, I'm going to be flipping back and forth between this program and my TI Inspire graphing calculator. And for the sake of time, I'm not going to do it on the 84, but if you ask me tomorrow in class, I will show you exactly how to do all of this on your 84s. All right. So, Vertex principle of linear programming. Your maximum and minimum values will always occur at one or more of your vertices. All right. Let's look at a problem. It says you are screen printing t-shirts and sweatshirts to sell at the Polk County Blues Festival and are working with the following constraints. You have at most 20 hours to make shirts. You want to spend no more than $600 on supplies. You want to have at least 50 items to sell. And if you look over here at the price tags, one t-shirt takes 10 minutes to make. It costs $4 to make, and you get $6 profit. And a sweatshirt takes 30 minutes to make. The supplies cost $20, and you get $20 in profit. So it says, how many t-shirts and how many sweatshirts should you make to maximize your profit? And how much is your profit? All right, the first thing we need to do here is we need to set up our constraints. Our constraints, it's simply going to be a system of equations, okay? So let's set up the first one. We know we have 20 hours to make shirts. It takes 10 minutes to make a t-shirt, 30 minutes to make a sweatshirt. All right. So we know that it takes 10 minutes to make a sweatshirt plus 30 minutes to make a sweatshirt, 10 for t-shirt, 30 for sweatshirt. And we know that we have no more than 20 hours. So it's less than or equal to 20 hours. Convert that to minutes. 20 times 60 is 1,200 minutes. So this is our first constraint. All right. It takes 10 minutes to make a t-shirt plus 30 minutes to make a sweatshirt. That has to be less than or equal to 20 hours or 1,200 minutes. All right. So we have this one. Now, you want to spend no more than $600 on supplies. All right. So we want to spend no more than $600. So 600, and our equation will have to be less than or equal to that. Well, if we look, t-shirts cost $4 to make, so 4x, plus sweatshirts cost $20 to make, so 20y. So $4 times a t-shirt plus $20 times a sweatshirt will need to be less than or equal to $600. All right, so we got that one. You want to have at least 50 items to sell. So t-shirts plus sweatshirts will have to be greater than or equal to 50 because we want at least, okay? We want at least 50 to sell. Now, we have two more constraints here, all right? We're going to be constrained by our x-axis. X has to be greater than or equal to 0 because obviously we can't go below 0 shirts, and y will also have to be greater than or equal to 0 for the same reason. We can't have less than 0 sweatshirts. So we're going to be, so these here are I said that backwards, constraints. Come on. C-O-N-S-T-I. All right, these are our constraints. Again, let's just go over this. It takes 10 minutes to make a shirt. T-shirts are X, sweatshirts are Y. It takes 10 minutes to make a shirt plus 30 minutes to make a sweatshirt. That has to be less than or equal to 1,200 minutes because 1,200 minutes is 20 hours. And that's our first constraint. Then we want to spend no more than $600 on supplies. So it costs $4 to make a t-shirt plus $20 to make a sweatshirt. That's going to have to be less than or equal to $600 because we don't want to spend more than $600. We want at least 50 items to sell, so number of t-shirts plus the number of sweatshirts will need to be greater than or equal to 50. And of course, we can't make less than 0 t-shirts and we can't make less than 0 sweatshirts. So here we have our constraints. Now we need to get our objective, whoops, left out the V, function. All right, we want to get our objective function. That is our profit. We're trying to maximize profit. All right, we're trying to maximize profit. So we know that our profit is $6, it says right here, $6 per t-shirt plus profit here, $20 per sweatshirt. So this is our objective function, which we're going to be finding the maximum of, and these are our 5 constraints. All right. Now, the next thing to do here is to graph these 5 equations. Now, you might be saying, they're not solved for y. Well, that's okay. All we have to do is pull up our Inspire, go to the graph like we did today in class, go to Menu, Graph Edit Entry, go down to Equation, go to Line, and then go to Line Standard Form. Now, if you see here, we have ax plus by equals c. So let's type in our first equation. It was 10x plus 30y equals 1,200. Now, we're not really so much worried here about the greater than, less than, or equal to, things like that, so just graph them as lines. Okay, you don't have to graph them as inequalities. Now, nothing showed up. That's because we need to adjust our window. So, go back to Menu, go to Window Zoom, Window Settings. For your X-min, put 0 because we can't have less than 0 shirts. For the X-max, let's put 150. For the Y-min, let's put 0. For the Y-max, let's put 50. And then hit OK. Now, there's our line. So now we go back to Control G. Let's type in our second one. It was 4x. Oops. It was 4x plus 20y equals 600. All right, so there's our second one. Control G. Let's type in our third one, which is 1x plus 1y, yes, you need to put the ones, equals 50, because we want 50 shirts, at least 50 things to sell. Okay. Now, go back to Menu, go to Edit, Graph Edit Entry, Equation, Line, but do vertical line this time, and do x equals 0. We need this, and I'll show you why later. And then go back to Menu, Graph Edit Entry, Equation, then go back and just click on Function, and then put f of x equals 0 and graph that. Now, if you remember from the Vertex Principle of linear programming, the maximum or minimums appear at the vertices of the feasible region. So, let me move this out the way. So, where these two lines cross is a vertice, where these two cross is a vertice, where these two down here cross is a vertice, and these two cross is also a vertice. All right, here, I'll move this up so we can see a little better. Let me move this label out of the way. All right, now, so we need to find the intersections of these 4 points. And then what we need to do is test those values in our objective function, okay, or our objective equation, okay? So here's how we do that. Go to Menu, Analyze Graph, Intersection, then it says Graph with the question mark, pick a graph, pick this graph, then it says Lower Bound. Basically, you're just go to the left of it. upper bound, go to the right of it, and it'll give us the intersection. So that intersection is 25, 25. Now let's do this one down here. So we go back to menu, analyze graph, intersection, pick this line, go to the left, go to the right. So that is 50, 0. Now let's do this one. Same concept. Menu, analyze, intersection, pick this graph, that one, lower, upper, and then add, will it undo? Yes. All right, let's move this over here so we can see it better. Now let's get our last one, which is right here. Again, menu, analyze graph, intersection, pick the red line, pick the blue line, lower, upper. So this one is 75.15. Now, at one of these values, which we're going to test them and figure it out, at one of these values, our maximum amount of profit is going to occur. Okay, we need to test all four so we can find our maximum amount of profit. All right, so make sure you have these 4 points written down: 25, 25, 50, 0, 75, 15, and 100, 120, 0. Make sure you have those written down. And let's go back to here so we can look at our objective function and we can solve for these. All right, so our first point was 50, 0, 25, 25, 75, 15, and 120, 0. All right, so now we want to plug these values into here. So P equals 6 times 50 plus 20 times 0. And that equals, this is 0, 6 times 50 is 300. So P equals 6, that's a 6, times 25 plus 20 times 25. And if you do this out, you get 650. Trying to save time. I know this video is going long. P equals 6 times 75 plus 15 times, oops, the 20 was supposed to be on the outside. So 6 times 75, 20 times 15, that'll give us 750. And test the last one, 6 times 120 plus 15, oops. I'm gonna go ahead and change that one like it should be too. 20 times 15 plus 20 times 0 equals 720. So now that we've put all four of our vertices that we just found from the graph, now that we've put them into our objective function and solved it out for all four sets, we see that at 75, 15, we have our maximum amount of profit, $750. So what does this 75.15 mean? Well, since we made X t-shirts and Y sweatshirts, this means that we can maximize our profit by selling 75 t-shirts and 15 sweatshirts. All right. And our maximum amount of profit, so our max profit is $750. Okay. That is linear programming. They either give you the constraints in the objective function, or they give you a word problem like we had, and you have to come up with your constraints and your objective function, which isn't too bad. Then you graph your functions that you did, or that you got like we did here. We graphed our 5 constraints, and you find the intersections of the graphs. Now, we didn't need to worry about these two here, this one and this one, because they're outside our feasible region. This quadrilateral right in here, constrained by this black line, this purple line, I guess, this blue line, and this red line, this is our feasible region. Every point inside of here will solve this system. But as you just saw, this point 75.15 right here, that will give us our maximum amount of profit, which is what we wanted. All right, and if you notice, 300 is our smallest number, so selling 50 t-shirts and no sweatshirts will give us our smallest amount of profit of only $300, which really doesn't make sense because if we spent $600 to make stuff, we don't want to only get $300 back. Okay, so now I want you to try one. All right, I'm going to go to the next page, but it has to do with this, so make sure you've written this down. Okay, so I want you to try this one. It says if it took 20 minutes to make a sweatshirt, how many of each type of shirt should you make to maximize your profit? All right, so I want you to try this. It uses the same problems as before, but you have to change one equation. I want to see if you can figure out which equation you're going to have to change, and then figure out the new max profit. All right, figure out the new max profit. All right, so as we had before, our equations we had before were 10x plus 30y is less than or equal to 120. I'm just recopying down everything. X plus y greater than or equal to 50. 4x plus 20y less than or equal to 600. And then, of course, x is greater than or equal to 0, or y is greater than or equal to 0. So these were our constraints. And, of course, our objective function was p equals 6x plus 20y. Okay, 6x plus 20y. Now, if it took, oops, that's 30y. If it took 20 minutes now to make a sweatshirt, which one of these is going to change? Hopefully you picked the first one, because this is 10 minutes for a t-shirt plus 30 minutes for a sweatshirt equals 1200. So this one's going to change from 10x plus 30y to 10x plus 20y. The rest of these constraints are going to stay the same, and our objective function is going to stay the same. Because remember, this 20 is $20 profit, whereas this 20 is the amount of time it takes to make your sweatshirts. Now, what we're going to have to do, we're going to have to change one of our graphs. All right, Control G. The one we're going to have to change is this one. It's going to go from 30y to 20y. So it's going to change our slope a little bit. So now we have to find this intersection point here. If you notice, the other one stayed the same, but we're going to have to change this intersection point right here. So remember, to do that, you go Menu, Analyze Graph, Intersection, pick the red graph, pick the blue graph, lower, upper. So that's 100, 10. So our other points stayed the same. The only one that changed is this one. It went to 100, 10. All right, so let's go back to here. So our point 100, 10, because we know the other points. Okay, let me bring this over. We know all of these points, so we don't need to redo these because our objective function is our objective function stayed the same. So the only one that we need to throw out is this 7515 one here. That's the only one we need to throw out, because that is the point that changed. It changed from 7515 to 110. So let's redo that one point only. 110. So P equals 6 times 100 plus 10 times, 20 times 10, and that's 600. And this is 200. So our total is 800. So as you can see, the point that changed is still our maximum profit at $800. So if it took 20 minutes to make a sweatshirt, how many of each should we make for maximum profit? We need to make 100 t-shirts. We need to make only 10 sweatshirts. And our max profit is going to be $800. Okay? So that is linear programming. I know this video went kind of long, but feel free to watch it as many times as you need to, and make sure you come to class tomorrow ready to work some problems. All right? See you tomorrow.